So welcome to week 5 of virtual class, and our topic that we're going to be learning about and practicing this week is scripts in motion in Scratch. So if you look at our information for today, May 14th, again, our topic is going to be writing scripts and creating motion in Scratch projects. And our objective, students will plan and write code to move a sprite or graphic around the stage or the area where all the action takes place in Scratch. Our essential question today is an interesting one. How is math connected to coding? Because as we learn how to start writing scripts and creating motion, we're going to see what a huge part of coding math really is. And that's all I'm going to tell you right now. You'll see in a minute. All right, so our goals for today are to learn about different block categories and block shapes in Scratch. I'm going to introduce you to two. And then you're going to learn about coordinates in Scratch. So there's a little bit of a clue about how the math is going to tie in. You are going to practice writing some scripts with me today, and then we'll preview this week's assignments that will be due by Monday at midnight. And as it is with every week, assignment number 1 is going to be a quiz, and assignment number 2 is going to be an activity that this week you'll be doing in Scratch. So with that being said, let's jump right into it. I want to start off by quickly reviewing with you some stuff that we talked about a couple weeks ago when we discussed vocabulary. In Scratch vocabulary, one of the terms that we talked about was the word blocks, all right? And blocks in Scratch are programming commands that you can snap together to form instructions, right? So when we're talking about programming in Scratch, we're telling sprites what to do. So in order to tell them what to do in a way that they understand, we use these blocks that we snap together almost like puzzle pieces to give them strings of instructions for what we want them to do and when. You can see that blocks have all different types of shapes, and today you're going to be learning specifically about this one right here, which is called a hat block, and right beneath it, this one here, which is called a stack block. Okay, but we'll get into that in just a second. But remember, blocks are commands that we snap together to form instructions for our sprites. We also learned a couple weeks ago about the term scripts. Scripts are the instructions that determine what happens on the stage. So when we take these blocks and we snap them together, we call those snap together blocks a script. And it's basically a chunk of code. Okay. And for a sprite, you could have 100 different scripts, all telling it to do different things at different times. But we call one of these a script. Okay. So with that being said, let's go ahead and start talking about the first shape of block that we need to understand, which is a hat block. So you can tell a lot about what a hat block's purpose is by looking at its shape and even looking at its name, right? If you think about a hat, you put a hat on the top of your head, right? So in this case, your hat block goes at the top of a script because it's the block that starts a script. If you look at the shape of a hat block, you'll notice that at the top it's smooth and there's not really any place for another block to snap on top of it. There's only a spot for a block to snap underneath it down here at the bottom. So hat blocks are always found at the very top or beginning of a script. In Scratch, our hat blocks are categorized by color and type. All right, so we're going to find our hat blocks, almost all of them, under a category called events, which is kind of a goldenrod yellow color. And I'll show you in Scratch. Let's see here, right? So if I'm looking at the Scratch programming environment like you see on the stage, over here, all the way on the left-hand side, you'll see all different categories of blocks. So when I click on these buttons over here, I can scroll through and look at different types and shapes of blocks. You're going to find all, not all, but almost all of your hat blocks under the events category. Okay, so you can see all of the ones that were on my screen right here. Go back here. So they tell your sprite when to start a section of instructions. Okay, so if you want your sprite to do something when the green flag is clicked, okay, the green flag being in the top left corner of your project up here, right? Then you would use this hat block when green flag clicked. Now in Scratch, all you have to do is click on that block and drag it over into your coding area right here, right? Let's say you want your sprite, in this case it's Scratch Cat, to do something when a certain key is pressed. Like think about video games that you might play on your computer, right? When you hit the right arrow, maybe a sprite moves to the right, or you hit the up arrow key, maybe it jumps, right? So if you want something to happen when a certain key is being pressed, then you can use this block right here, which you'll notice has a drop-down menu. When you click on that little white arrow, you'll see that you have different options for different keys that you can use in this hat block. So if I want something to happen when, let's say, the W key is pressed, I can select W here, and any blocks I put underneath this, they'll take place anytime I hit the W on my keyboard, all right? If I want something to happen when I click on a certain sprite, so think about maybe a game online where you click a button to start, or you click a button to set settings or something like that, then you can use this hat block right here when this sprite clicked. And because I have Scratch Cat selected down here, these instructions will apply to him anytime that I take my mouse and I click on it, okay? Those are the ones that we are going to be, those are the majority of the ones that we're going to be using in STEM Integrations 1. So really these first three that I just highlighted are the ones that you're going to be focusing on today and for most of your work for this class. These other ones, they have a time and a place. We're just not really going to get to it so much this year. All right, so those are your hat blocks. And again, those blocks start a script. All right. The other type of block that we're going to be talking about are stack blocks. And again, we can tell a lot about a stack block by looking at its name and its shape. So stack blocks are blocks that you stack one on top of the other, all right? And they just give single commands, all right? So they tell a sprite to do this, do this, do this, do this. If we want a sprite to do one thing, we can put one stack block underneath our hat block. If we wanted to do 20 things, we can put 20 of these blocks together to tell our sprite what to do and in what order, okay? So a stack block is a block that gives a command. All right, we find the ones we're going to be using for today's assignment, because remember, we're learning how to write scripts about motion. You're going to find them under the blue motion category in Scratch. So I'm going to hop over to Scratch and we're going to talk about each of these really quickly because this is probably where you're going to have most of the questions whenever you start your assignment. Actually, we might come back to these in a second. Let's keep going with our PowerPoint and we'll hop back there in a minute. So these blocks, they deal with commands that deal with how a sprite moves. So you'll notice that if you look at these blocks, you're going to see a lot of numbers, right? And you would think if you were talking about movement that you would see more words like left, right, up, down, right? But you don't see that. You see numbers. That's because if you think back to what we learned at the beginning of when we talked about Scratch, computers are really, really great at understanding numbers, but they don't really speak English like us. So if we can communicate to computers with numbers, the computer is really going to understand that. So we use that to our advantage whenever we're coding. When we talk about motion in Scratch, we're talking about X and Y coordinates. And these are just like the XY coordinates that you learn about and talk about in your math classes. So you have probably, I'm sure, in your math classes, plotted points on a coordinate grid or a coordinate plane. Your teachers use different terms, I guess, to refer to it. But we're talking about a grid that has an x-axis and it has a y-axis, okay? And when we talk about moving a sprite to a specific place on our stage, any place we put our sprite on the stage is going to have an x, y coordinate location on that stage, okay? So important rules to remember, and you can always come back to this PowerPoint and take a look at it, but important rules to remember is that positive x values move a sprite to the right. So let me explain that. Here's our sprite, and here's our x-axis. On this side of the x-axis, we have positive numbers, okay? And on this side of the x-axis, we have negative numbers, all right? If we want a sprite to move to the right, we need to make sure that we have a positive x value. If we want a sprite to move to the left, we need to make sure that we have a negative x value, okay? And that's because right in the center here, we have 0. Anything higher than 0 is a positive number. Anything lower than 0 is a negative number. So let me show you what I mean in Scratch, okay? So I'm going to get rid of these. And you can see to delete a block, all I have to do is click on it, drag it back here, and just let it go, and it'll disappear. I can also right-click on it and delete the block if I want to. Okay, all right, so I'm clicking on motion, my blue motion category here, and you guys can see, let's look at our set X and set Y buttons. I'm going to take these, I'm going to drag these out. Now we said that if we wanted a sprite to move to the right, we needed a positive X value, okay? So that means that if I put a positive number in this box, Scratchcat, our sprite, should move somewhere to the right, okay? The right side of the stage. So let's make that number, let's make it 150, okay? And when I click on this block, you're going to notice that Scratchcat is going to follow the instruction, right? One way we can get the Scratchcat to do, what we want them to do is by clicking on individual blocks, or if we want to run a script, we can add a hat block and make it happen when the green flag is clicked or a key is pressed or whatever. But I'm just going to click on this block so you can see what happens. We're going to test it. And you can see I added a positive number and Scratchcat moved to the right half of the stage, right? Let's experiment and see, because remember the rule is negative X values move a sprite to the left. So let's test this out. Let's make it negative 150. Let's click on the block and see what Scratchcat does. You'll see he moves to the left half of the stage, right? So the exact center is your origin, 0, 0, just like in math class. And if you want a sprite to move to the right, you've got to give it a positive X value. If you want it to move to the left, you've got to give it a negative X value, okay? So if we go back to our PowerPoint, you'll see the exact same thing is the case for our Y values. A positive Y value will move a sprite up, and a negative Y value will move a sprite down. Again, let's go to Scratch and let's test this. Okay, so if we want Scratchcat to move up, we should be able to give it a positive, notice this number is positive Y value, and he moved up. And if we want Scratchcat to move down, make it negative 150, a negative value, click on it, you'll see he moves down. Okay, so really when we're talking about right, left, up, and down, we're talking about positive and negative X and Y values. Okay, if we want Scratchcat to go to a specific place, okay, we've got a block for that, right? So maybe whenever I click on Scratchcat, I want him to go to a specific place, right? There's a block here that says go to X, Y. All right, and this block can basically allow us to send Scratchcat to points that we have plotted, right? So let's say I want Scratchcat to go right here. I can see those X and Y coordinates right here for whatever sprite that I have selected or highlighted in blue down here, right? So I have Scratchcat selected, and any place that I move him, I can see what those X and Y coordinates are. All right. So if I have this block pulled out right here, let's say I want Scratchcat to go right there, I can see that the coordinates that I want to plot or tell him to go to would be negative 173, 102. I can come up here to this block and type in negative 173 and 102. Okay, I'm going to move him someplace else. And you can see anytime I click on that block, he's going to go to that point that I plotted, those two coordinates. Okay, so this is one way that math is related to coding, especially video game design. All right, so I'm going to do a little practice with you. I want you to try to see if you can answer these as I go. If I told a sprite, we'll say Scratch Cat right here, to change his Y by 10, would he move up, down, right, or left? If you said up, you are correct. Changing the Y by 10 or adding to the Y axis, all right, so more than 0 is going to move a sprite up. Let's say I told a sprite to change its X by 25. Which direction would the sprite move? If you said to the right, you are correct, right? We're adding to the x-axis, which means a sprite would be moving to the right. If I told a sprite to change its x by -5, which direction would it move? If you said to the left, you are correct. We are subtracting on the x-axis. So we're talking about a negative number. We're moving to the left. And last, if we told a sprite to change its y by -100, would it move up, down, right, or left? If you said down, you were correct, right? We're subtracting, or we have a negative number. We're moving down the y-axis. We're moving down as a sprite, okay? So this is how our XY coordinates influence the way that a sprite moves. We can plot points, or we can make a sprite move in a direction or send them to a specific X or Y location, or both. And math is a really big part of that. All right. So now you can think about maybe quadrants. All right. I know these aren't the same as the quadrants you use in math class, but I've just labeled them up here on this graphic: A, B, C, or D. Okay. So I want you to think, if I told a sprite to go to -100, 100. Okay. You can see the block up here. Would our sprite land in A, B, C, or D? If you said A, you are correct, right? We are subtracting on the x-axis and adding on the y-axis. That would put us somewhere in quadrant A. Excellent job. If we told a sprite to go to x100, y100, would it land in A, B, C, or D? If you said B, you're correct, because we are adding to the x-axis and adding to the y-axis. Very good. If we told a sprite to go to -100, -100, would it be an A, B, C, or D? If you said D, you are correct. We are subtracting from the x-axis and subtracting from the y-axis. And the last one, if we told a sprite to go to x100, y -100, which quadrant would it land in, A, B, C, or D? And if you said C, you are correct. We are adding to the x and subtracting from the y, which would put us somewhere in quadrant C. Okay, so now that we got that, the other type of coordinates we have to talk about are polar coordinates. Okay, and polar coordinates are coordinates that deal with a sprite's direction, specifically the direction that it is pointing towards. Okay, so instead of using words like up, down, right, and left, again, we use numbers to describe the direction a sprite is pointing. So in this case, 0 is up, 90 is right, 180 is down, and -90 is left. Now, back in the day, students had to memorize these, but they updated Scratch somewhat recently, so they've made this really easy for you. There is one block in particular that deals with pointing in direction, and this is the point in direction block. Okay, and this block right here, whenever you click on the number to change it, a little compass will show up. It almost kind of looks like a clock. And instead of having to memorize those numbers, you can just use the arrow and click and drag it to point in different directions. So you can see left is -90, down is 180, right is 90, and up is 0, right? So pointing in direction. If you want a sprite to point in a certain direction, this is the block that you use, okay? Let me see if there's anything else here, because there's a few other blocks that I want to show you. Okay. So for example, which direction is the sprite pointing in this picture? And the correct answer is 0 degrees. Which direction is the sprite pointing in this picture? He's looking left, so he's pointing in negative 90 degrees. What direction is the sprite pointing now? He's pointing down, which is 180 degrees. And last, what direction is the sprite pointing here? The sprite is pointing right, which would be 90 degrees. Okay. All right, so that is it. There's a couple other blocks and tricks that I want to show you before you get started with your assignments this week, right? So I do want to point out this pointing in direction button, and I want to point out, we'll start at the top, I guess. So if we look at all of our motion blocks for your assignment, you're going to be using quite a bit of them. And I want to show you a little bit about what they do. So you can try experimenting on your own if you'd like to as well before you start the assignment. So you have this block right here, which says move 10 steps. So moving in Scratch or moving steps in Scratch means that a sprite is going to move 10 positions in the direction that the sprite is facing. Now, not every sprite actually has a face where you can easily see which direction it's facing, but you can figure it out by using this block, right? This one is pretty easy because we can see that he has a face and he's right now facing right. So if he's facing right, the moving 10 steps block will actually make him move 10 positions to the right. Okay? Now, if he was pointing left, which I can show you, we can make the sprite, let's make it point to the left. Okay, he's pointing to the left now. He's upside down, but we'll talk about that in a second. But he is pointing to the left. When I make him move 10 steps now, you'll see that he's actually moving to the left. So it's the same block, but what he does changes depending on which direction he's facing, right? So if I, let me talk about this problem right here, because this is going to come up in your assignment too. You'll notice that he flipped upside down whenever I want him to point to the left. This is because we have not told him how we want him to rotate those degrees to turn to the left. If you ever in a situation where you're in a project and you've noticed that your sprite is turning funny, like it's flipping upside down or it's not spinning the way you want it to, it's just not moving the way you want to, think about adding this block right here. It's towards the bottom of your motion blocks and it says set rotation style. So if you look, there's a drop-down menu and you have different options. You can set a rotation style to left to right. You can tell a sprite not to rotate at all, or you can tell it to set its rotation style to all around, and they all have their purpose. But if we have our sprite who's turning from right to the left, we want to set a rotation style to left right. Now, when I put these two instructions together, you'll notice that he'll face the left without flipping upside down. And I can have him go ahead and turn and face the right now. And he looks great. And go back over to the left. And you'll see I fixed that problem of him flipping upside down. And the way I did that is just by adding this block and setting the rotation style. Before, the rotation style was set to all around, which means that like a clock, he turned around this way and ended up flipping upside down instead of just kind of like a mirror image going left and right. So you'll see now when I set the rotation style all around, he flips upside down, right? So the rotation style I want is left, right. If you ever have a problem that's similar to that, think about your rotation style, okay? With that in mind, let's talk about this block right here, the turn 15 degrees block. So what do you think will happen whenever I click on this block for the cat? Okay, if you said that he's going to spin around, excellent guess. But look at what happens whenever I hit this block. He's just flipping from the left to the right. Now remember, I told you, and every couple of clicks, he kind of flips back and forth. I told you if you run into a situation where a sprite isn't moving the way that you think it should, that something seems a little bit off, think about your rotation style. Think about adding that block. So remember our other options we had here. We have set it to left, right with this script right here. But if we want him to spin, the rotation style we want is probably all around, okay? So when I set my rotation style to all around, now you'll see that he's spinning around or rotating the way we initially pictured it, right? Okay, so that setting rotation style block is super important, very important for this assignment right here. Another thing I want to talk to you all about that'll help you with the assignment, a common question I get, is the difference between these blocks and these blocks, okay? So when we talk about X and Y, right, getting a sprite to move left, right, up, and down, students oftentimes get these blocks kind of mixed up with each other, but they have different purposes, okay? So you'll notice that two of these blocks right here that I've taken from the motion category deal with changing X, and two of them deal with, or changing Y, and two of them deal with setting X and setting Y, okay? These words, change and set, mean very, very different things. To change means to add or subtract from, right? So changing the X by 10, and I'm going to make all of my numbers 10 here so you guys can see what I'm talking about, okay? Changing the X by 10 means that every time I click on this block or every time I give this command, Scratchcat is going to move 10 positions to the right. Because every time I click on it, I'm changing it by a positive number, I'm adding 10, right? Same thing for changing the Y by 10. Every time I click on this command, Scratchcat is going to add 10 more to its position, okay? But look at what happens when I click set X to 10. Think about what set means, okay? Clicking it again, he moved one time, but suddenly he stopped. That's because when I set the X to 10, just like I was plotting a point, I told Scratchcat to go to 10 on the Y-axis and stay there. I set it there, right? Think about whenever you have an oven and you set the temperature to 350 degrees, right? But what if I told you when the oven was set to 350 degrees to change it by 350 degrees? Then suddenly it would be 700 degrees, right? So changing and setting are two different things. Look at what happens when I click set Y to 10. Okay, he moves, but I'm continuing to click on it and he's not moving anymore. That's because we set it to 10 positions above 0, okay? So make sure that you know the difference between those two blocks. Let me see if there's anything else that's important for you to see. Gliding. Remember we talked about this one is being able to plot a certain position, right? So if you want the cat to go somewhere, you move him there. You can see his XY coordinates right here, and you can put those numbers in this block. Going to a certain place is going to make your sprite like teleport there, right? 1 second it's, I'll show you right here. 1 second Scratchcat is here, but when I click on this command, then in a blink of an eye, he jumps over here, right? That's like teleporting. When you say go to, teleporting. But you also have the option to do gliding, right? And you can glide to a specific XY location, or you can glide to, for example, an object or a random position. And you can see when I click on this command, he's not teleporting. We can actually see him traveling from point A to point B. And if we want to change how fast he's traveling, we can change the amount of time here. So I could tell him to glide for 5 seconds to a random position, right? And it slows him down. Or I could tell him to glide half of a second to a random position. He'll speed up, okay? So you can use that glide block to do that. Anytime you see a drop-down menu, always click there to kind of experiment and see what's available. We're working with writing motion scripts this week, but a lot of these principles are relevant to a lot of the projects that we're going to have. So never be afraid to experiment in Scratch. If you make a mistake, you can always delete the last script you wrote and start fresh. For your assignment for this week, let's talk about what it is so you all can start experimenting and get started with it. For your assignment, Scripts in Motion, for this assignment, you will create an assignment that fulfills all the instructions on the attached checklist. When your project is done, it should look like and work just like the project demonstrated in the attached video. When you're done, please remember to share and add your link to this assignment before turning it in, okay? So basically, for this assignment, I've given you a checklist like last time. To create a new project, you're going to keep Scratchcat, but you're going to add a new backdrop called Bedroom 3 from the library. and you're going to add a musical instrument sprite to your project, and then you're going to write scripts to make Scratch Cat do all these different types of movements. So he will go to the bottom left corner when the green flag is clicked. Make him go to the musical instrument when you click on him. Make him go to the top of the bed when the B key is pressed, and jump up 10 Y positions when the J key is pressed, and spin when the S key is pressed, and point left and move left when the left arrow key is pressed, and point right and move right when the right arrow key is pressed, okay? So it looks like a lot, but once you get going, this really is very simple, and this is just the basics of programming. So for this, you will see that we have been let me go back to this. We've just been writing, we haven't been writing full scripts. We're just using kind of blocks to just experiment with different commands. But remember, this week we learned about not just these stack blocks, but also the event hat blocks, right? So we can tell him to do certain things based off certain events, right? Because he's not just doing those things, but we want him to do something specific when the green flag is clicked, right? So if we want him to go to the bottom left-hand corner, then we will put him there, find his XY coordinates, and say, when the green flag is clicked, go to that XY location, right? So anytime I click the green flag, he'll go there, all right? This is a completed script. And for this assignment, you're going to need a ton of them. But you'll see it's just 2 blocks. So they're not long scripts, they're short ones. You just kind of have to organize your thoughts, think computationally to figure out how to get everything done. Whenever you are done, there's a video of this, but I'll show you a demo to what the completed assignment looks like. Here it is. Okay, so you can see, I don't have mine shared yet. Make sure you don't forget to share, but I'm just going to make this full screen and show you. I don't want to cheat and show you the scripts, but remember, he's going to go to the bottom left-hand corner when the green flag is clicked. There he goes. He should go to the musical instrument when I click on him. There he goes. He should glide to the top of the bed when the B key is pressed. It's great. He should jump up 10 Y positions when the J key is pressed. He should spin when the S key is pressed. I'm holding it down. All right. And he should move right and face right when the right arrow key is pressed. Point left and move left when the left arrow key is pressed. And that's the assignment. Okay. So check out that checklist. Think about everything we talked about. Feel free to go back and look at the PowerPoint. Look at the video. Come back to this video if you need a little refresher. And look in Google Classroom for the common questions posed, because I'll put some videos there for questions that I receive a lot of as we kind of move over the next 5 days. So yeah, best of luck, and let me know if you have any questions. Shoot me an email.